All right, in this problem, we are given two parametric equations, x equals 3 plus 3t and y equals 4 plus t. And we're told that these two, that the x and y variables that are produced by these two equations form a straight line when we graph them. And you can see it over here. Here's our straight line. I'll get that in a second. And then we're asked about a series of points and whether or not these points are on the line or not on the line. So here's what I've done. I've taken our two equations for x and y and our variable t, and I made a table here. So I've got different t inputs from 0 all the way down to 10. I just want to sort of investigate these patterns a bit. And then I have our x outputs here. They start at 3 and they go up by 3s, getting to 33 at the end. And then our y outputs, which start at 4, and they go up by 1s until they reach 14. So each of these points, 3, 4, 6, 5, 9, 6, these are all points on the line. I can go over here, and here is the line itself. I suppose it's not, so it starts here. I mean, I suppose it could go negative if t were negative, but it stretches up through here. Here's all the points that I plotted. And here are the points that we're asked about. Now, just by viewing them, you can see that these two are on the line, but these two are not on the line. But if we didn't have the line to check, how could we figure this out? Right, so that's what we're going to do next. So first, let's check 8, 8. And remember, 8, 8 is not on the line. Okay, so there must be some t that outputs an x equals 8. So let's figure out what that t is using the equation. I'll substitute 8 for x, and I have 3 plus 3t. So let's see, I'll subtract 3 from each side. I have 5 equals 3t. I'll divide by 3, and 5/3 equals t. So if this t produces an 8 for x, it should also produce an 8 for y. So a couple different ways we could go about checking this. We could, in fact, actually let's do it this way. Let's plug in 8 for y in that equation. 8 equals 4 plus t. I'll subtract 4 from each side, and I get 4 equals t. So to get the point, to get the x-coordinate 8, I would have to input a 5/3 for t. To get the y-coordinate of 8, I'd have to input a 4 for t. So I don't have a single t value that produces both those two same x and y coordinates, which means that if I were to find them on this table, they would not appear across from each other, so they're not on the line. They're not a single point on the line. Let's check 12(7). So I'm going to plug in 12 for 3 plus 3t. I'll subtract 3, 9 equals 3t, and then I'll divide by 3 and get 3 equals t. So if I input 3 for t, I'll output 12 for x. Now let's see what happens when I go to y, and this time instead of solving for y, I want to substitute this 3 in for our rule in y. So it's be 4 plus 3. So y equals 7. And we check. Well, that's the output we expect. So this t value of 3 gives us both a 12 and a 7. So check. That number is on the line. Let's check down here for 17.7. And we can see 17.7 is not on the line, so we should end up with a no for that one. So let's use the last method for this one. So we're going to solve for t using x, and then we're going to input that variable in for y and see if we get the number we're expecting. So let's see, our x is 17. So 17 equals 3 plus 3t. So we'll solve for t. So I'll subtract 3 and I get 14. You know it. 14 equals 3t. Divide by 3 on both sides. 14/3 equals t. So let's see if I substitute 14/3 into the other equation, do I get the output that I'm shooting for? So let's see. Y equals 4 plus 14/3. Well, that's just 4 and 14/3, which will compare is not 7, so that one's a no. This one, by the way, up here was a no, too. All right. Last one is 21/10. So let's check here. This one we can see is on the line, so we should get the correct one here. So let's see. I'll use the first method on this one. So let's see. We have, we're going to substitute 21 for x equals 3 plus 3t. We'll take 3 away from each side. I get 18 equals 3t. Divide by 3, 9 equals t. Pause for that. Okay. So we solve for t, meaning that if I plug a 9 in for t, I'm going to output 21 for x. So let's see if I plug in 10 for, if I solve for 10. So let's see here. 10 equals, hold on a second here. Hold on a second. I noticed something was wrong here, and I had all this distraction going on. 18 divided by 3 is not 9, it's 6. So if I plug in a 6 for t, I'll output a 21 for the x variable. So let's see, 10 equals 4 plus t, subtract 4 from each side, 6 equals t. So using the y equation, if I input a 6, I will get a 10. So the same input produces the two outputs that I want, which means that they'll appear, actually you can see them here, 21, 10, they appear next to each other on the table, meaning that they are an XY pair on the line. So if we want to check if a certain point is on the line described by a pair of parametric equations, one thing we could do is we could just make a table of values and then plot those points and then check, does that point appear on the line or is it not on the line? Of course, the problem with that is that, what if it was really close? Maybe you're not sure if it's quite on the line or not. So visually, that could be a problem. But this method will work out every time. So one of two things. Either I set each equation. So I replace x with the x output that I want. And here I place y with the y output. And I solve both equations. And if I get the same t value both times, which down here I do, that means that those are on the line. I get different t values up here, meaning different inputs produce 8 equals x and 8 equals y, so they're not the same, they don't appear across from each other on the table. Whereas these two do, so they're a point on the line. The other thing you can do is you can solve for a particular t value, like I did here. So I substituted 17 into the equation for x, solve for t, and I found that if t is equal to 14/3, then we will output a 17 for x. And then I'll just plug that number into the y equation and see if it outputs a 7 like I expect. And here it didn't. So we know that the point 7, 17 isn't on the line because the point 17, 4 and 14/3 is. Over here, we did the same thing. I put 12 in for x, and then I solved the equation to find out that if 3 is equal to t, we're going to output a 12. And then I went ahead and substituted 3 into the y equation for t, and it tells me I'll output 7 for a y, which is what I expect, which means that the point 12.7 is on the line. All right, so two different approaches there, both of them illustrated, to check and see using algebra, and not just by visually looking at the line, whether or not a point is or is not on the line. And we're finished.